We're going to be looking at laws of logarithms. We're going to be using properties of logarithms to expand and condense logarithmic expressions, to simplify logarithmic expressions, and to evaluate logarithmic expressions. We're also going to be looking at something called a change of base formula. Remember, while you're listening to the video, to take good notes, and anytime you need to pause and rewind to review a concept, be sure to do that. Let's go on to the next frame. We're going to be looking at 3 laws of logarithms. The first law is log base b of m times n being equal to log base b of m plus log base b of n. In other words, a logarithm of a product is equal to a sum of logarithms. The second law is log base b of m divided by n is equal to log base b of m minus log base b of n. In other words, the logarithm of a quotient can be equal to a difference of logarithms. And the third law is log base b of m raised to some power k is equal to k times log base b of m. We'll be able to bring exponents on expressions inside of logarithms down in front of the logarithm as a multiplier. Let's go ahead. Let's take a look at some examples, beginning with the next frame. In this first example, we're asked to express the logarithm in terms of log base 2 of m and log base 2 of n. I'm looking at log base 2 of the cube root of m squared times n. And the very first thing I'm going to do, I'm going to take this logarithm and express it as log base 2, and instead of saying the cube root of m squared n, I'm going to express this radical as a rational exponent, and so I'm going to call it m squared n, that quantity raised to the 1/3 power. And so the first property I'm going to use, I'm going to say, let's go ahead, let's take that exponent, 1/3, and let's bring it down in front. And I can now say this is going to be 1/3 times log base 2 of m squared times n. The second property I'm going to use is the property that says I can take a product that's inside of a logarithm and express this as a sum of logarithms. So I'm now going to turn this into, I have the 1/3 out in front, and I'm going to be careful because that 1/3 needs to be multiplied over the quantity. And inside of my bracket, I'm going to say log base 2 of m squared plus log base 2 of n. All right, I've almost completed it now. The very next thing I'm going to do, I'm going to take a look at log base 2 of m squared, and again, I'm going to use the property that says I can bring the exponent down in front. And so now I'm going to write this as 1/3 times this quantity of 2 times log base 2 of m plus log base 2 of n. The very last thing I'm going to do, I'm going to distribute the 1/3 over the addition, and so finally 1/3 times 2 will give me 2/3 log base 2 of m plus, and then 1/3 times log base 2 of n. And I have completely expanded my logarithm so that the logarithms have one expression inside each of them. In this example, I'm looking at log base 2 of a quantity m divided by n raised to the 7th power. And again, I'm being asked to expand this logarithm. And so I'm going to begin by using the property about the exponent that says I can take the exponent and bring it down in front of the logarithm. So I'm going to begin by saying that this is equal to 7 times log base 2 of m divided by n. I have a quotient inside of my logarithm. I'm going to be using the property that says a logarithm of a quotient can be expressed as a difference of logarithms. And so I again am going to make sure that my 7, all right, that's out in front, is going to be multiplied over the entire quantity. So I'm going to open up a bracket, and then I'm going to turn log base 2 of m divided by n into log base 2 of m minus log base 2 of n. And then finally, the very last thing I'm going to do, I'm going to distribute my 7 over the subtraction sign, and my answer will be 7 log base 2 of m minus 7 log base 2 of n. We're being asked to evaluate log base 10 of 9/2. Now I know that the base 10 is written there. It doesn't always have to be, because remember, when there's nothing written there in that little base area, it's known as a common log, and we automatically assume that it is base 10. Okay, the 10 is written there, and that's okay. We'll just use it the way it's written. Log base 10 of 9/2 is what we're looking for. They've given me some information. They've told me that log base 10 of 9 is equal to 0.95, and log base 10 of 2 is equal to 0.30. And I'm going to use that information to help me find the value of log base 10 of 9/2. I'm going to be using some properties to expand this logarithm, because I noticed that inside of the logarithm are the 9 and the 2. The property that I'm going to use is the one that says a logarithm of a quotient can be written as a difference of logarithms. And so the very first thing I'm going to say, I'm going to turn this into log base 10, or common log of 9, minus log base 10, or common log of 2. Now I have a difference of logarithms, and I've got my logarithm expressed with 9s and 2s. And I'm going to use some substitution. I know that log base 10 of 9 is equal to 0.95. And so I'm going to substitute in 0.95. And I know that the common log of 2, or log base 10 of 2, is equal to 0.30, and I'm going to substitute in 0.30, and then I'm going to go ahead and complete the operation. 0.95 minus 0.30 gives me 0.65, or 65/100ths. And so I now know that the common log of 9/2, it is equal to 0.65. Now you try one. If the common log of 9 is equal to 0.95 and the common log of 2 is equal to 0.30, find the common log of 162. We need to express 162 using 9s and 2s, and then use laws of logarithms to expand the expression and substitute in their values. Go ahead and hit pause on the video and try to find the common log of 162. We know that the common log of 162 can be expressed as the common log of 2 times 81. 2 times 81 is equal to 162. And I know then that I can express this as the common log of 2 times 9 to the second power. There is a product between 2 and 9 to the second power, and so I'm going to use the law of logarithms that says the logarithm of a product is equal to the sum of the logarithms. And I'm going to write this expression as the common log of 2 plus the common log of 9 to the second power. I know that there's a law that says I can bring an exponent down in front of a logarithm. And so I'm now going to express this as common log of 2 plus, and bringing the 2 down in front, the common log of 9. I'm now ready to substitute in. I know that the common log of 2 is equal to 0.3, and so 0.30 plus 2 times, and I know that the common log of 9 is equal to 0.95. 0.95. And I'm ready to do the arithmetic. 0.30 plus 2 times 0.95, 1.90, and 0.30 plus 1.90 is 2.20. And so the common log of 162 is equal to 2.20. Now we're going to be looking at some examples of condensing logarithms. We're going to take a sum of logarithms and we're going to express it as one logarithm, as a single logarithm. I'm looking at log base 5 of m plus 1/4 log base 5 of n. And the very first thing I'm going to do, I'm going to use that rule of exponents, and I'm going to take the number that's out in front of log base 5 of n and put that 1/4 back up in its exponential position. So the expression is now going to read log base 5 of m plus log base 5 of n raised to the 1/4 power. I'm going to take that rational exponent 1/4 and I'm going to take n to the 1/4, put it back into radical form, and so I'm going to call this log base 5 of m plus log base 5 of the 4th root of n. The property I'm going to use next is the idea of a logarithm of a product can be expressed as a sum of logarithms, except I'm going to use it the other way around, and I'm going to say the sum of logarithms can be expressed as a logarithm of a product. And so I'm going to turn this into log base 5 of m times the 4th root of n. And I've condensed down to one logarithm. In this example, we're being asked to simplify log base 4 of 3 minus log base 4 of 48. And so the first thing I'm going to do, I'm going to condense this down to a logarithm. I'm going to remember that a difference of logarithms can be expressed as a logarithm of a quotient. And so I'm going to write this as log base 4 of 3 divided by 48. I now have this quotient inside of my logarithm, and 3 over 48 can be simplified. I can turn this into log base 4 of 1 over 16. Now, notice that I have a base 4 logarithm, and that the number 16 can be expressed as 4 to a power. So I'm going to say, let's go ahead, let's turn this into log base 4 of 1 over 4 to the second power. And then I'm going to go one more step further, and I'm going to say 1 over 4 to the second power is the same thing as 4 raised to the negative 2 power. I'm going to relocate my 4 up into the numerator, and I'm going to make the exponent become negative. So I'm going to write this as log base 4 of 4 raised to the negative 2 power. Now I've got a logarithm whose base is the same as what's inside of the logarithm. I have that exponent of negative 2 on what's inside of that logarithm. So I'm going to use that property that says take that exponent and bring it down in front. I'm going to turn this now into negative 2 times log base 4 of 4. And I know that log base 4 of 4, remember a logarithm is nothing more than an exponent. It's the kind of exponent when I put it on its base, I get what's inside of the logarithm. And so log base 4 of 4 is representing the number 1. 4 to the first power is equal to 4. So I can now write my expression as negative 2 times 1, and so my value is equal to negative 2. The expression log base 4 of 3, log base 4 of 3, minus log base 4 of 48 can actually be simplified to be negative 2. Finally, the last property we're going to be looking at here today is called the change of base formula. The change of base formula is going to enable us to take a logarithm of a base and rewrite it in terms of any other base that we choose. And so the formula says log base c of a can be written as, and I can choose any base I like, log base b of a over log base b of c. Notice in the numerator, the a is what was inside the original logarithm, and the c is the old base of the logarithm. And so I could say log base c of a could be written as the common log of a over the common log of c. Or log base c of a could also be written as the natural log of a over the natural log of c. I can choose any base I like. Typically, the bases that I'm going to choose are going to be bases that I can use off of a calculator. And so more than likely, we'll be using change of base formula to convert on over to common logs and natural logs, which are base e. Let's evaluate log base 5 of 13. Since we don't have a log base 5 on our calculator, we're going to use the change of base formula and convert on over to, and let's use the common log first. Let's turn this into the common log of 13 over the common log of 5. Now go ahead and hit pause on the video. Put the common log of 13 divided by the common log of 5 into your calculator, and then go ahead and start the video up again. The common log of 13 divided by the common log of 5 is equal to 1.593. We're going to use 3 decimal places of accuracy. That's what we'll agree on. What I'd like you to do now, I'd like you to go ahead and, instead of using common logs, let's use natural logs. Let's express this as the natural log of 13 divided by the natural log of 5. Go ahead and pause the video, use your calculator again, and then put the video back on. If you did it correctly, what you've noticed is the natural log of 13 divided by the natural log of 5 is also 1.593. Remember, in using that change of base formula, we can choose any base that we like and get an appropriate answer. Now, we're not saying that the common log of 13 is equivalent to the natural log of 13, but we are saying that the ratio of the common log of 13 divided by the common log of 5 is equal to the natural log of 13 divided by the natural log of 5. In that change of base formula, we can pick any base we like and get the appropriate ratio. Let's go ahead, let's evaluate log base 4 of 48. Let's turn log base 4 of 48 into the common log of 48 divided by the common log of 4. Go ahead, hit pause on the video and put that into your calculator. The common log of 48 divided by the common log of 4 is equal to 2.792. And then let's go ahead, hit stop on the video again, and this time switch on over to natural logs and evaluate the natural log of 48 divided by the natural log of 4. Again, you will have noticed the natural log of 48 divided by the natural log of 4 is also 2.792. I hope you have taken good notes while watching this screencast. If you need to go back and review some of the concepts, be sure to do that. We will address any questions you still have in our class discussion, and we'll practice using these concepts in class. Thank you.